Hello, everyone. This video is tied to Pre-Calculus, Unit 1, Topic 4, Operations with Rational Expressions is what we're going over today. And I had actually started recording this video and then something happened, so I'm starting over again. So at least with the first couple of problems, I'm just going to walk you through what I already went through in the last video, and then we'll start doing them by hand here. So let me go ahead and get started with that. So we're going to cover adding rational expressions that have like denominators, adding rational expressions that have unlike denominators, multiplication, and lastly, we'll do division. Okay, so this is just so that you have a permanent video to refer back to for how to do this. Okay, so let's get started with adding with like denominators. So when you have like denominators, you can combine the numerators over that same denominator. It's that logic that 1/2 plus 1/2, if you have half a pizza and another half of a pizza, that's going to add up to be a whole pizza, right? So 1/2 plus 1/2, you can combine 1 plus 1 over 2, which is 2 over 2, which is 1. It's the same logic we're using for rational expressions. So the first example we have is 3 over x plus 1 plus 4 over x plus 1. You can just combine 3 and 4. So that's 3 plus 4 is 7 over x plus 1. There's nothing really to simplify. You're pretty much done with that one. Second example here, just a little bit more complicated. You still have that nice like denominator, so you can combine everything over 4x. But one thing to be careful about, and this is something that students get tripped up with a lot, is you're subtracting 4x minus 1. You're subtracting the entire numerator. So it's kind of like distributing the -1 to the 4x and to the -1. So the 4x will be negative when you combine the terms, and then the -1 will be a +1 because you're subtracting both things. So just be really, really careful. Make sure whenever you're subtracting, you change every sign in what you're subtracting. Okay, so that's going to end up being 3x minus 4x plus 1. 3x minus 4x is just -1x. Then we have plus 1 over 4x, and that's it. For the last one, go ahead and give it a try. You can pause the video and give it a whirl, and then we'll look at the answer after you're done working on it. Okay, good job. So this one, you combine the terms. Remember to change the signs of everything that you're subtracting. So this is -3 here. 4a minus 2a is 2a minus 3, and then it's all over a minus 3. Okay, moving right along. What about when you have unlike denominators? You have to make them alike. So what we do usually is we multiply one or both fractions by a form of 1 that will get you the same denominator. So here we have 3 over x minus 5x divided by 6x. X is a factor of 6x. This is great. When you have one denominator that is a factor of another, you just multiply by what's going to get you that denominator. So x times 6 will be 6x. But whatever you do in the denominator of fraction, you also have to do in the numerator, because you don't want to break any math rules. You have to multiply by a form of 1. So you have to also multiply the numerator 3 times 6. So 3 times 6 is 18. So you can combine everything over 6x. 18 minus 5x over 6x is your full answer. Okay, here's another example right here where it's not as obvious here what you can do, but you can look to factor. Always be factoring when you're dealing with rational expressions and see if things will cancel for you. X squared minus 4 factors as x minus 2 times x plus 2. You can either do it the way where you look for terms that multiply to c and add to b, or you can remember that this is difference of perfect squares, which always factors as minus the square root plus the square root. Now that you've factored, you can see that this is similar to this problem. This denominator is a factor of this denominator. All you need is the x minus 2 to make them both the same. So I'm going to go ahead and multiply both the numerator and the denominator of this second expression by, or the second term, x minus 2 over x minus 2. And then I can combine. So x minus 2 times x minus 2 divided by x minus 2, x plus 2. Okay, and just to see what happens, I'm going to go ahead and distribute. So we'll do x minus 2x plus 2, because that negative, again, like we were saying, negative gets distributed to both terms. So you have to make sure that you change the sign. So x minus 2x is just negative x plus 2. So that'll be negative x plus 2 over x minus 2, x plus 2. It doesn't really look like anything else needs to be done. I think I guess you could factor out the negative 1 here. So negative 1 and then x minus 2, and then you could cancel them. So let's go ahead and do that. I'll do that on this part here. So we could say this is negative x minus 2 divided by x minus 2 times x plus 2. And then that will cancel through, giving you negative 1 over x plus 2. Sorry, I went off the page a little bit. So that would be a fully simplified answer for this. Okay, go ahead and give this one a try. I think I've already gotten you started with a little hint here. Go ahead and pause the video, try this one. All right. Hopefully you got it. This is what we need our denominator to be. So we multiply both the numerator and the denominator of this expression by what's missing. We distribute, combine like terms, and if there's nothing to simplify, we'll leave it. Okay, so that's when you have unlike denominators, you have to make them alike. What we're going to do now is shift to multiplication and division. So multiplication and division, you don't really need to worry about like denominators. You just have to make sure that your factoring is pretty good. Both greatest common factors and factoring quadratics. So 3x plus 3 over x minus 2 times x squared minus 4x plus 4 divided by x plus 1. So we're going to factor as much as we can, because all this is asking us to do, just like with this, is just simplify. So if I look at 3x plus 3, 3 is the greatest common factor of both of these terms. So I can actually write this as 3 times quantity x plus 1, right? Over x minus 2, nothing I can do with that. And then we have x squared minus 4x plus 4. You can factor that quadratic expression as x minus 2 times x plus 2, and then all divided by x plus 1. Okay, now that you've factored everything, you can treat this as one big fraction, kind of, right? It's all multiplied together. So what you're going to do now is look for, okay, what divides out to 1 here? What divides out to 1? Well, I see x plus 1 over x plus 1. I see x minus 2 over x minus 2. And that's about it. That leaves me with 3x plus 2. And if you'll remember from Unit 1, Topic 3, if this were a rational function, these would be removable discontinuities, right? These would be holes. You'd have a hole at -1, x equals -1, and you have a hole at x equals 2. So just connecting that knowledge back. So our final answer would be 3 times x plus 2, or you could distribute and say it's 3x plus 6. Okay. All right, let's do another together. X squared minus 1 over 4 times 8x over x plus 1. X squared minus 1, again, if you were looking at these two examples, that's a difference of perfect squares. So that's going to factor as x plus 1 times x minus 1. I have to leave 4 alone, nothing to be factored there. Have to leave 8x alone. Have to leave x plus 1 alone. Okay, I think we've factored everything that we can factor here. So what I'm going to go ahead and do is think now, okay, what divides out to 1, or what can divide out? I have x plus 1 over x plus 1. And I have, 8 and 4. 8 divided by 4 will simplify, right? That's just 2 over 1. Okay, so now that's leaving me with, I have x minus 1 still, I have 2 still, I have 2x still. So I can say what I'm left with is 2x times x minus 1, or if you wanted to distribute it, that would be fine. It would be 2x squared minus 2x. Both of those are correct, but that's what you would end up getting. Okay, and now I'm going to invite you to try this problem. Pause the video, give it a whirl, just factor and cancel what you can cancel, divide out what you can divide out. All right, good work. the numerator of this first term, the first expression does factor. X plus 1 and x plus 1 divide out. 16 divided by 8 is same as 2 over 1. So you'll have 2x plus 2 or 2x plus 4. Okay, lastly, we've got division, which the only change with division is when you're dividing by a fraction, it's the same as multiplying by the reciprocal. So if you remember, I'm going to take you back a little bit. If you were taught dividing fractions previously, let's say you had 3/4 divided by 5/6, you were probably taught that that's the same as 3/4 times 6/5, right? Flipping was the way I learned it when I was in school. You flip the second, you flip the divisor, you flip the fraction that you're dividing by. So it becomes a multiplication problem. So dividing rational expressions, you just change it into a multiplication problem by taking the reciprocal of the divisor, which is then becomes just like a multiplication problem. So the easy way that I remember it in my mind is flip, factor, cancel. Flip the divisor, factor just like you do with multiplication, and then cancel or divide out what you can. So let's flip first. So I'm going to leave the dividend the way that it is already in here, right? So x squared plus 4x plus 3 over 9. I don't flip that, but I'm going to turn this into multiplication by multiplying by the reciprocal of this. So this will now be 6 over x plus 3. Okay. Now it's a multiplication problem, just like these. I factor what I can factor. So x, this is x plus 1, x plus 3 over 9 times 6 over x plus 3. Okay, what divides out? X plus 3, x plus 3. 6/9 is 2/3. Okay, so my final factorization, my final answer would be 2 times x plus 1 over 3. And that's it. I'm going to leave it like that. You can distribute 2x plus 2 over 3. That's fine. I'm just going to leave it like this. Okay. All right. Second example. Okay. Writing it down. We're going to start by flipping the divisor. Take the reciprocal of the divisor. So we've got 4x squared plus 2x over x plus 4 times, because we're flipping, x plus 3 over 2. Okay, now we're going to factor. Can I factor anything? Here you do see that there is a greatest common factor between 4x squared and 2x. You can actually divide out 2x from both of those terms. So let's do that. So this will be 2x, and that leaves me with x plus 1 all over x plus 4 times x plus 3 over 2. Okay. This is not quite as satisfying as the other ones. You don't get to do as much slashing through. The only thing that really divides out is your 2 here. So that's going to leave you with x times x plus 1 times x plus 3, all divided by x plus 4. And if you're connecting this back to Unit 1, Topic 3, if this were a function, it would have x-intercepts at 0, -1, and -3, and a vertical asymptote at x equals -4. And it would have not a horizontal asymptote, but it would have a slant asymptote, right? Because the degree of the numerator is 3 and the degree of the denominator is 4. So again, just wanting to connect you guys back to that knowledge there. Okay. All right. Try this problem. Remember, flip, factor, cancel. Pause the video and we'll reveal the answer. All right, so hopefully you guys got it. X squared minus 36 is wonderful difference of perfect squares. So what ends up canceling is the x minus 6, the x plus 6. So really all you're left with when you're done is just 1 divided by 3, or 1 over 3. All right. So feel free to rewind the video, go back to some spots that you needed a little more help with, pause it, email me questions if you have any. Thank you for watching, and I'll see you next time.